Bases combine with hydrogen ions to neutralize the acids. Some of them dissolve in water to form solutions containing hydroxide ions, which are called alkalis. For example, lithium hydroxide, sodium hydroxide, potassium hydroxide, etc. These are proton acceptors. So in this very video, I am so fired up to break down about 8 types of bases. So make sure to give this a thumbs up if you see value in this content, and make sure to hit the word subscribe down below. So let's dive in. So number 8 is the Bronsted-Lowry base. This is an acid-base theory which is proposed on 1923 by two friends, Nicholas Bronsted and Thomas Martin Lowry. This concept goes like this. Now suppose if an acid and a base react each other, the acid makes its conjugate base and the base makes its conjugate acid. This occurs when an exchange of a proton occurs between the acid and the base. Number 7 are Lewis bases. These have a pair of electrons but not used in bonding, but could form a coordinate bond or a dative bond with Lewis acids. It's called a Lewis base because it donates its lone pair of electrons. Lone pair of electrons are pair of valence electrons that aren't shared in a bond. These are a chemical species that have the properties of organic compounds and the properties of a base. These are sometimes called proton acceptors as well. Number 5, basic oxides. These basic oxides react with water to form bases and react with acids to form salt and water. Strong acids are the number 4 on this list. These remove protons from weak acids. For example, lithium hydroxide, sodium hydroxide, and nearly every alkali metal plus the hydroxide. These can increase the concentration of hydrogen ions, and these are very less soluble in water. Super bases are the next one on this queue. Very strong but very weak when considering hydrogen or protons. Next is the non-nucleophilic base. The chemists need some chemicals to remove protons very easily. Nucleophilic can, but non-nucleophilic is very quickly they could remove the protons from the bases. Number 1, weak acids. They do not fully ionize with aqueous solutions. For example, ammonia is an example of weak bases. So this is the second part of this video series. So if you need to watch the part 1 of the series, click right here on the screen, and if you need to watch another series of mine, click right here and alongside with the round subscribe button, and I will see you in the next video.